Okay, let's dive in. Think about this. You have these incredibly smart AI models, right?
Mm-hmm.
But they're kind of locked in, stuck
Yeah.
with only the data they were trained on.
Yeah, exactly. They have these knowledge cutoffs. They can't see real-time information. It's like a brain in a jar almost.
Right. So the puzzle is, how do we connect that brain to the real world, the live data, the tools we use every day?
And that really hits on the core challenge. Connecting AI to all those external resources, it's not simple.
Right.
People talk about the Mayan integration problem. Lots of AI models, M models, and tons of tools. Connecting each one to each other, that gets incredibly complex uh, really fast.
Okay, so for this deep dive, we're looking at two main ways folks are tackling this. First, there's LLM tool calling. You
Yep.
might also hear it called function calling.
Right.
And second, this newer idea, the Model Context Protocol, or MCP.
Yep.
And our goal here is basically to figure out, is MCP just like a fancy new name for tool calling?
Yeah.
Or is it something genuinely different, maybe more powerful?
That's the key question. And tool calling, well, it came about specifically to help LLMs break out of that box.
How does it work? Like the gist of it.
So the LLM itself, it figures out, okay, to answer this question, I need to use an external tool, like check the weather or look up a stock price.
Got it.
Then it generates a structured output, basically a request saying, hey, application, run this function for me with these details.
So the AI isn't running the code itself, it's just asking.
Precisely. It identifies the need, formats the request, the application around the LLM does the actual work, calls the API, queries the database, whatever it is.
And that lets it get past those knowledge limits, access live info, automate stuff,
Yeah,
connect to other systems. Makes sense.
exactly. You define the tools upfront, tell the LLM what's available. It detects the user's intent, creates the structured request, the app executes it, gets the result, and then feeds that result back into the LLM so it can use it in its final answer.
Okay, clear enough. Now let's switch gears to MCP. You hear it described as an AI USB port. What's the idea there? Is it just about making connections easier?
Well, yeah, but it's more foundational. If tool calling is like specific cables for specific devices, MCP aims to be that universal standard USB-C for AI, maybe.
Ah, okay. I like that.
It's an open protocol designed to create a common language between AI systems and external tools or data sources. The big goal is solving that M by N problem by standardizing the communication.
So how does this USB port actually function? What's the architecture?
It uses a client-server setup. You have a host that's the main AI application, maybe like Claude Desktop or an IDE like Cursor.
Okay.
Inside the host, you have clients. Each client connects one-to-one with an MCP server, and these servers are what actually offer the capabilities, the tools, the data, maybe even preset prompts.
Interesting. So the LLM isn't talking directly to the server.
No, that's a key point. The host and its client act as intermediaries. They manage the interaction. The LLM talks to the host client talks to the server.
What kinds of things can these servers provide through the host?
MCP defines three main interaction types. They call them primitives. First, there are tools.
Okay, like tool calling.
Pretty similar, yeah. The LLM decides it needs a tool, asks the host, and the host client makes the call via the server. Think API calls, database queries, actions. The model initiates the request here.
Got it. What else?
Second, resources. And this is where MCP starts to look quite different. Resources are more about data or context files, database entries, emails, whatever.
Okay. How is that different from a tool fetching data?
The key difference is control and initiation. With resources, the host application often decides what context the LLM needs and provides it proactively.
Proactively, so before the LLM even asks.
Exactly. The host might see your question, understand you're asking about a specific project, and then push the relevant project documents from a server into the LLM's context window. It's like anticipating the need. Think of it like a GAT request, usually not causing side effects, just fetching info.
Huh. That is different. Application controlled context. What's the third primitive?
Third one is prompts. These are predefined instruction templates. Either the user or the host application can trigger them to guide the LLM. Oh, and there's one more feature sampling. Servers can actually ask the host's LLM to perform a completion or do some processing for them so the interaction can go both ways.
Wow, okay. Tools, proactive resources, prompts, even the server using the LLM. That sounds much broader than just asking for a function to be run.
It is. So if we contrast them directly, tool calling is really an LLM feature, often specific to a model provider's API. MCP is an open protocol, a standard.
Right. And initiation.
Tool calling is mostly LLM initiated. MCP is mediated by the host client, and resources are often host initiated. Control and tool calling is kind of shared, but MCP puts more control, especially around security and data, with the host.
And the scope is obviously wider for MCP tools, resources, prompts, sampling versus mainly function execution for tool calling.
Absolutely. And that proactive context provisioning via resources is a core differentiator. Tool calling is generally reactive, the LLM asks, the app fetches. MCP adds that proactive layer managed by the application.
Plus, standardization. MCP aims for protocol-level standards, not just API or library conventions, and maybe better security through that host control.
That's the idea. The host acts as a gatekeeper, managing permissions and consent before data or tool access happens.
So wrapping this up, it really sounds like MCP isn't just another way to do tool calling. It's aiming to be a much more comprehensive architecture.
Yeah, that's the takeaway. It's a broader paradigm for how AI systems integrate with the world, offering more structure, more control points, and these different interaction patterns like resources.
And we're seeing it pop up.
Early days. But yes, Anthropic's Claude uses it, some other tech players are involved, and there's an open source community building MCP servers. It's gaining traction.
Okay, so here's something for you, the listener, to think about. As AI gets deeper into everything we do, which way seems better? The more direct, LLM-driven tool use we see in standard function calling, or this more structured, protocol-based approach like MCP with the application having more control?
Yeah, what's the right balance between AI, autonomy, flexibility, application control, and overall security?
Definitely food for thought as we see how these AI applications evolve and connect in the future.